Welcome! This video explores doing divide and conquer problem solving with lists using recursion. So I'm going to be demonstrating using a BYOB script. You can download it. It's called the Divide and Conquer Starter. You can download it as a zip file. And in that zip file is just the BYOB project. You can extract that and then open it up, which I've already done. So here it is, Divide and Conquer Starter. It has a list already built for us. Not a big deal. But more importantly, it's got these two blocks. First half of list and second half of list. And they do just what they sound like. If I say, take my list numbers and give me the first half, it says, okay, that's 2 and 5. If I say, take my list numbers and give me the second half, that's going to be 8 and 9. You don't have to worry about how they work. If you want to, you can go in and check out the code by editing it. It just uses things that we have available in the basic blocks and does the work for us. And if this list gets longer, they still work correctly. So there's 9 SDF WE, and the first half is 2, 5, and 8. Now, I can take the second half of numbers, and because it's giving me a list, I can use that as the input to another half of block. So give me the second half of numbers, that's 8 and 9, and now I just want the first half of 8 and 9. Well, that's 8. Or I could say, give me the second half of the second half. That's 9. Or start by giving me the first half of numbers, which is 2 and 5, and then I only want to see the second half of 2 and 5, which is 5. So by using these half of blocks, I can keep chopping the list up until we get down to one thing. We're going to use these in this idea of chopping the list until we get down to one thing to build our functions. And the first function we're going to build is a function to add up this list of numbers. So we're going to go and look at how it's supposed to work before we build the code for it. So I want to add this list of numbers together. The way I can think about this recursively is, how do I add 4 numbers? Well, I break it into 2 lists of 2, to 2, 5, and 8, 9, and I add up those 2, and I add up these 2, and then I put the results together. Okay, well, how do I add up a list of 2 numbers? Well, I can break each list of 2 numbers into 2 lists of 1 number. All right, this process should look very familiar from the merge sort. So I've split the list of 4 into 2 lists of 2 and then into 4 lists of 1. Well, how do I add up a list of 1? Well, that's easy. I don't have to even add. I just take 2, 5, 8, 9. All right, I get down to this point and there's nothing to think about. The answer is obvious. And that's kind of what we do when we're trying to do recursion. We break the problem down until we get to an obvious simple case. Hey, there's just one number, that's the answer. And now we build our answer back up from those simple cases. So this one says 2, this one says 5. So those 2 together must be 2 plus 5, or 7. 8 and 9, so those 2 together must be 17. So now I know the first half of the list was added up to 7. The second half of the original list added to 17. So how do I get the total list? Well, I add up what the first half is and the second half. 7 plus 17 makes 24, and that's the sum of my original list. So we're going to write a recursive function to go through and do this process. And it's going to be deceptively simple. Right? There's a lot of work that's going to go on behind the scenes. But the kind of beauty of recursion is that the algorithm we can use to express all that is going to be relatively straightforward, or at least relatively short. So I'm going to make my block. It is add numbers in list. It's a list block. It sounds like a reporter because it's going to give us back a number. And the %list is just going to make my parameter for me automatically, so I don't have to put that in. If I want, I can go force it to only take lists. So we want to have this recursive function. Anytime I'm doing recursion, I know I need an if-else. Are we down to the simple case? If so, here's our answer. Otherwise, here's the complex step. So our simple cases, we're down to one thing. So to say we're down to one thing, I just need to check and see, is the length of the list that I'm currently working with 1? If so, then I know the answer. All right, if I'm down to one thing, then the answer I need to report is that first thing in the list, that one thing. So I'll report item 1 of whatever list I'm currently working with. And I don't want to have numbers here because I want this to be flexible, and I need to be able to work with those little lists that we're going to generate along the way. So that's the simple case. The complex case would be, well, okay, how do I do something like 2,5 or 2,589? Well, I go do the same process. I add up the two halves of the list, right? I split it into two and add up those halves and then add them together. So in BYOB, what this would look like is my answer, so I'm going to report, is going to be the result of adding all the numbers in the first half of the list to all the numbers in the second half of the list. So I'll go use these new blocks, and this is where the first half and second half come in. So I want to take the first half of the list and the second half of the list, and I want to add up all the numbers in the first half, and I want to add up all the numbers in the second half, and when I get my answer from adding the first half, I'll add it to the result from adding up all the numbers in the second half of the list. And if there's 4 things in the list, I'll split into 2 lists of 2. And then to add those lists of 2, I'll split them into lists of 1. And that's where we'll get the answer from. And when we get that answer back, we'll put that together with the other number to get our result. So let's try that. Add numbers in my list called numbers. 24. Perfect. All right. Like I said, kind of deceptively simple, a very short chunk of code. We don't have any repeat block. It all just kind of happens through this magic of recursively calling ourselves until we get down to a list of one thing. Now, I'm going to look at one other example. So I can add up all the numbers. I'm going to make another block that tries to find a value. I want to see if this list has the number 8 in it. Okay, so let's make a block. This is going to give us an answer, but the answer is either true or false. So that's what a predicate is supposed to be. So I'm going to use that. And it works on a list. And so I'm going to call this %list contains thing. And so the %list and %thing will give me my 2 parameters. And I'm going to just go set this so that it only takes lists. And here's what it looks like. Does this list contain, and I can put in 8. Does numbers contain 8? Well, so we've got to figure out how to apply that same logic from the add numbers to deciding whether or not this list has something. We're going to do kind of something very similar in terms of we're going to keep breaking up the list, and when we get down to one thing, the decision's easy. If I'm down to one thing, is that thing what I'm looking for? All right, so let's start with our if-else. And our first test is going to be, are we down to one thing? So is the length of my list So the length of the list I'm working with, is it 1? If so, we want to check and see if the current item is what we're looking for. So let's do another if-else. Is the current item, so item 1, because we're down to one thing, does that equal the thing that we're looking for? So item 1, if item 1 of the list equals the thing we're looking for, then yes, it's in that list. So we can return true. And if not, we'll report false. So I just need to grab the report blocks and put those in. All right, so here's our base case. If we're down to one thing, and that one thing is what we're looking for, then the answer is true. Otherwise, it's false. So at this point, I'm just going to go test what we've got. And to test it, I'm going to use one of these kind of disposable lists and just have one thing. So does the list of 8 contain 8? Why, yes, it does. Does the list of 7 contain 8? No, it doesn't. Okay, so let's go back in and build up the recursive step, the complex step. So if my list is down to one thing, I can decide yes or no, I've found the thing or I haven't. If we're not down to one thing, we need to use the same basic logic. We're going to make our answer, we're going to report our answer as being what the 2 halves of the list find. So I'm going to start by building up just like we did in the add numbers. I'm going to split the list up. So I'll go use our first half of this list and second half of this list blocks. And what I want to do with each half is to do this again, ask, hey, first half, do you contain the thing I'm looking for? Second half, do you contain the thing I'm looking for? And then kind of put those results together. Now, putting those results together when we were doing the adding numbers means adding up the 2 halves. For what we're doing here, asking if in the list contains something, we're going to get back, we can't add the results because we're going to get back true and false, and adding up true plus false doesn't really make sense. What we need to say is use logical operations and or. And if I'm looking for a number in the list, if I find it in either half, that's good enough. Right? So logically, that's or. If it's in the first half or if it's in the second half, then the answer is true. If it's not here and it's not there, that's the only case it's false, if we have 2 falses. So here's my final version of does this list contain something is, well, are we down to one thing? If so, is it the right thing? If so, yes. Otherwise, no. Otherwise, we've got more than one thing left. Well, let's chop it into 2 halves. And if either half contains the thing I'm looking for, then that's true. So let's try it with our does numbers contain 8? Why, yes, that's true. Does numbers contain 4? No, that's not. We look at the first half of the list and the second half of the list. The first half of the list looks at 2 and 5 and splits it up. 2 says nope, 5 says nope. So the first half of the list says, well, I've got false and false or false. That's still false. Second half of the list says false for 8. 9 is false, so I'm false. First half of the list said false, second half of the list said false, so the final answer is false. And essentially we're adding up the results using or, using this logic of we just need true in either one of these things, and then we'll be true. important thing to recognize here is that we've got this nice basic recipe. The details change a little bit for kind of what I do with that final item. If I'm adding things up, the answer for one item is its value. If I'm looking for something, what I do with one thing is check and see if it's the right thing, and then report true or false based on that. And the logic changes for how I put things together. So if I'm adding up the numbers in a list, then I just need to add the two halves of the list. If I'm looking for something, I need to say, well, does the first half contain it, or does the second half contain it? But the basic process of splitting the list up, dividing it into two halves, and then doing our job on those halves is the same.